Welcome to today's video. Whether you're trying to master your math skills or whip up something delicious in the kitchen, we've got you covered. First, we'll dive into the world of fractions, specifically how to add and subtract negative fractions. In our previous video, we discussed about adding and subtracting common and unlike denominators. It's easier than you might think. Then we're heading to the kitchen to make a mouth watering orange chicken and rice. Two great skills, one awesome video. Let's get started. So, as I said, our lesson for today is about adding and subtracting negative fractions. Let's begin. First, we will add negative fractions. We have here our first example, which is negative negative 2/3 plus 5/4. So that's negative 2/3 plus 5/4. Now, how are we going to solve this? Of course, we need to get the least common denominator. Okay, we're familiar with the least common denominator. All right, let us just use our pen first. Okay, so we will have to look for our least common, okay, least common denominator, or what you call the LCD. Okay, we're going to look for that. And how are we going to do that? Of course, we can see here that we have 3 and 4 as our denominators. Okay, the first thing that we need to do is to list the multiples of 3 and 4 for us to get the LCD. All right. So let's erase that. Okay, we have to list the multiples of 3 and 4 to get the least common denominator. Of course, we have 3 and 4. Now, this is just already a review of what we already know in listing multiples. So, of course, we have the multiples of 3 are the following. We have 3, we have 6, we have 9, we have 12. That's for the multiples of 3. And then for the multiples of 4, we have 4, we have 8, we have 12, and we have 16. Now, as we can see, the least um, of them for both 3 and 4 is actually 12. Okay? So that means this will be our LCD, or least common denominator. Remember, by listing the multiples of our denominators, which is 3 and 4, we will we are able to actually see what our least common denominator is. Okay, so in this case, our least common denominator is actually 12. All right. Now, the second thing that we need to do is to rewrite. Okay, we have to rewrite. Let's erase this one. We have to rewrite now. Hold on. Let us just click this one and erase this. We have to rewrite now our fractions. Okay, so we have negative 2/3. We have to rewrite it by multiplying both our numerator and denominator to 4. Okay, so we have negative 2 times 4, and then 3 times 4. So this would be, so what is negative 2 times 4? That would be negative 8. How about 3 times 4? That would be 12. So bear in mind that when you multiply um, you multiply your denominator to 4, you must also multiply your numerator by 4. Okay, so we have now negative 8 over 12. Okay, and then we will also rewrite or convert 5 over 4. So we will multiply both the numerator and the denominator by 3. Okay, so 5 times 3 would be equal to 15 over what is 4 times 3? 12. Why did we do that? Because our main objective is to make their denominators the same, right? Which is, that's why we have the least common denominator, which is 12. Now we can actually add them together. Okay, on this side, we'll add them together. So you have now negative 8 over 12 plus 15 over 12. You see that? That's the goal. Okay. Okay, and then we write 12 as our denominator, common denominator, and then 8 plus 15. Now, what is, oh, sorry, negative 8, I mean to say, negative 8, my bad, negative 8 plus 15. Now, what is negative 8 plus 15? Of course, that would be 7 over 12. So that is now our answer. All right. Pretty easy, right? It is. It's not just pretty easy, but it is easy. All right. Okay. So our answer for, if we're going to add negative 2/3 plus 5/4 would be 7 over 12. Okay. We move on. All right. How about for the second one? So we have here, what do you call this? We have here negative 3/8 plus negative 7 6, or we can also call it as we can also call this as negative 7 over 6. All right. So how will we solve this? Okay, it's just applying the rules that we've learned from adding, what do you call this, when we were adding on integers, right? Okay, so again, we have to list all the multiples of our denominators. So as you can see here in negative 3 over 8, our denominator is 8. And the second one, negative 7 over 6, um, the denominator is 6. So we have, again, to list all the multiples of 8 and 6 for us to see our least common denominator. Okay? So for 8, the multiples are the following. We have 8, 16, 24, all right, 32. I'm going to stop with 32. And for 6, the multiples are the following: 6, 12, 18, and 24. Obviously, we can now say that the least common denominator of 8 and 6 is actually 24. Again, we need now to rewrite first our fraction negative 3 eighths, or negative 3 over 8, by, of course, multiplying both our numerator and denominator to, we will multiply them to 3. Okay, so this will be, what is negative 3 times 3? That will be negative 9. Okay, and then 8 times 3 would be 24. Okay. And then we will also convert or rewrite negative 7 over 6, or negative 7 sixths. Okay. So we will also both multiply our numerator and denominator to 4. All right. All right. So what is negative 7 times 4? That is negative 28 over what is 6 times 4? That is 24. Okay. All right. So we need more space. So we need now to erase this one. I hope you're getting it. Okay. All right. Now, since we already have negative 9 over 24, all right, plus negative. So we have negative 9 over 24 plus negative 28 over 24. See, we now have a common denominator. Okay, we'll just write 24 as our denominator. So what is negative 9 plus negative 28? If you can still remember Mr. Dorito, um, yeah, well, Dorito math is actually applicable for multiplication. But in this case, when you're adding two negatives, the answer would also be a negative, okay? All right, so this would be negative. So let's add. So negative 28 plus negative 9. So that's 7. One up. Okay, so that would be negative 37. That's our numerator. Okay, over 24. So we now have uh, our answer as negative 37 over 24. But, you can actually change this into a mixed form, into a mixed fraction. This is actually considered to be an improper negative fraction. But whenever we want to simplify or reduce this into a mixed form, we're just applying the same thing with it, the same thing with improper positive fraction, regardless, of course, of our sign. Let's try to convert this into mixed form, of course. All right. Again, let's erase it for us to have more space, of course. So negative 37 over 24. Okay, if we're going to convert that, um, of course, we do the basic division, of course. So regardless of our sign, of course, okay, we put the negative sign aside first, okay. So we have 37 divided by 24. That would be 1. Okay, 1 times 24 would be 24. Okay, minus 37 minus 24 would give us 13. And of course, we now have negative 1 and 13 over 24. So the mixed form, okay, mixed form of negative 37 over 24 would be negative 1 and 13 over 24. Okay, that's pretty much easy for us to do. Okay, so again, the mixed form is negative 1 and 13 over 24. Of course, if we know the parts, okay, so negative 1 here is actually our, yes, it's actually our whole number. Yes, yeah, okay. And the fractional part is 13 over 24. Okay, or that's what you call as your, what do you call this? The fractional part. Yes, in your mixed form. Okay, the 13 over 24. All right, so this is the mixed form for negative 37 over 24. That would be negative 1 and 13 over 24. Yes, okay. And that it also makes sense because my strategy here is if you want to change this back to improper fraction. By the way, negative 37 over 24 is actually an example of an improper fraction. Okay, if you can still remember what an improper fraction is. Yes, so when we say improper fraction, that means that your numerator is actually greater or equal to your denominator. Okay, all right, let's move on. And I hope we're really making things easier for you to understand. All right, so we move on. And one more thing, if I may just add, if you want to change back the mixed form into improper form, it's pretty much easy. Again, disregard the sign first. So we have 1 and 13 over 24. When you multiply 24 by 1, of course, it's 24. And then 24 plus 13 would eventually give you back to 37. So that would again be then put back your negative sign, negative 37 over 24. Makes sense, right? Okay, makes sense. All right, let's move on. So that's for adding negative fractions. All right, how about subtracting negative fractions? Okay, so we're done with adding negative fractions. We'll now be dealing with subtracting negative fractions. Okay, so in this case, it's like following the rule of adding its opposite. Okay, so in this case, we have negative 7 over 20, okay, minus 5 over 25. So we have negative 7 over 20, okay, minus 5 over 25. Now, if I'm going to apply the rule of add its opposite, this will become negative 7 over 20 plus negative 5, okay, plus negative 5 over 25, okay? So I repeat, that would be negative 7 over 20 plus negative 5 over 25. All right. Now, again, the next goal is for us to get our LCD or least common denominator. And how will we do that? By, of course, listing the multiples of 20 and 25. All right. Yes, we need to list uh, down all the multiples of 20 and 25. So the following are the for us to get our least common denominator. The following, of course, are the multiples of 20. So we have 20, 40, 60, 80, and of course 100. I'll stop with 100. And then for 25, we have 25, we have 50, we have 75, and 100. So, by common sense, we can now say that our LCD, of course, is 100. Okay, so the least common denominator of 20 and 25 is 100. All right. Again, let's give more space because we have just, very limited space on our Google slide. Yes, that's true. All right, so let's erase them. Okay, let's erase it. Hold on. All right, now the next thing is to rewrite our fractions negative 7 over 20 and negative and of course negative 5 over 25. Again, our next goal is to rewrite um, negative 7 over 20 and negative 5 over 25. So let's start first with negative 7 over 20. Okay, so we will rewrite them. Okay, negative 7 over 20. We will both multiply our numerator and denominator by 5. Yes, okay. So what is negative 7 times 5? That would be negative 35 over what is 20 times 5? That is 100. Then you also need to convert negative 5 over 25 or rewrite. So negative 5 times over 25 times. So both your numerator and denominator will be multiplied to 4. So negative 5 times 4 is negative 20. Okay. Over um, 25 times 4 is 100. Okay. All right. Now we can add them, of course. Let's again erase that. Okay. It's kind of small. Okay. So we now have negative 35 over 100 plus negative 20 over 100. Okay, let's put 100 as our common um, denominator. And then we have negative 35 plus negative 20. So it's basically the answer now would be, let's put it over here. It's negative 55 over 100. But as you can see, negative 55 over 100 can actually still be simplified or reduced. Of course, if we can still remember our GCF. What is GCF? That is your greatest common factor. Now, by just looking at it, we can see that the greatest common factor between what do you call this, negative 55 and 100 is 5. So that means you can divide both your numerator and denominator by 5. Let's see. Okay. So negative 55 divided by 5 over 100 divided by 5. So it will now give us an answer of negative 11 over 20. Okay. That is our answer. Okay. Okay. So again, that's because negative 55 divided by 5 is negative 11, and 100 divided by 5 is 20. So our answer now would be negative 11 over 20. All right? Easy, right? Okay. Hope you're getting it. Okay, let's go to the next one. All right. Okay. I think this would be our last example about adding and adding and subtracting negative fractions. Okay, yeah, this is the last example, I believe so. Okay, so we have here negative 8 over 13 minus negative 11 over 2. So applying the rule, add its opposite. This would be negative 8 over 13 plus 11 over 2. Okay, because the opposite, of course, that's why it's called add. So you have to change this sign to add. And what is the opposite of negative 11 over 2? That would be positive 11 over 2. Now, again, for us to get the common denominator between 13 and 2, we need to list down our multiples for both of them. All right, so for 13, the following are the multiples of 13. So 13, 26. Sorry about that. 26, um, 39. All right, 52. So that's 13, 26, 39, 52, 65, right? Okay, we'll stop at 65 for 13. You know, the multiples of 13. How about for 2? I think we'll have a long list of multiples for 2. So you have 2, 4. Okay, so you know, for the multiples of 2, 2, 4, 6, 8, 10. Okay, 12, 14, 16. All right, 18. Oh, pretty long, huh? 20. Okay, next is 22. Next is 24. And of course, lastly would be 26. Why did I stop with 26? Because obviously the least common denominator, sorry about that, the least common denominator between 13 and 20, sorry, the least common denominator between 13 and 2 is actually 26. That's your LCD, right? Your LCD is 26. All right, pretty long for the multiples of 2. Okay, so let's erase that again. Oh, sorry. All right. Now, since we have our LCD now, the next step is to rewrite both negative 8 over 13 and 11 over 2. All right, so we'll start with negative 8 over 13, negative 8 over 13 will both multiply our numerator and denominator, both multiply our denominator by 2 by both multiply our numerator and denominator by 2. Okay, so what is um, negative 8 times 2? That would be negative 16. It's kind of hard to write here. That would be negative 16. Okay, and then 13 times 2 would be 26. Okay, and then for 11 over 2, okay, again, multiply both 11, which is our numerator, and 2, our denominator. We will both multiply them by 13. Yes, because we want to make our denominator the same, right? So what is 11 times 13? Okay, 13 times 11, that would be 3, 1. Okay, 3, 1. Okay, it's 143. Okay, so that would be 143 over 26. All right, pretty easy, right? Okay, not pretty easy, but super easy. So we now have negative 16 over 26, okay, plus 143 over 26. Okay, now we can add them. Okay, let's just erase. All right, so we have now negative 16 over 26 plus 143 over 26. All right, so negative 16 plus 143 over 26. Now, what is 143 minus 16? All right, so we borrow 1 from 14. Okay, so that would be 13 minus 6 is, okay, that's 7. And what's left here is 13. So um, that would be, yes, okay, 127. Yes, correct. So it will now become 127, 127 over 26. All right. But as you can see, if you want to change this to mixed form, we can actually. Hold on. So our answer is 127 over 26, but we can change that to mixed form if we like. 127, that depends also if you're having your test and in the direction it's telling you to change it to mixed form, then you have to follow what direction is given to you. So we have 127 over 26. All right, so all we have to do is just divide 127 divided by 26. So that would be 4. And 4 times 26 would give us 104. So 127 minus 104 will give us, okay, 3. And of course, this would be 2. So our would be mixed form would be 4 and 23 over 26. Yeah. Okay. So remember your whole number. This is actually your whole number. Um, your actually your quotient would be your whole number, and then your remainder will be your numerator, and of course your divisor will be your denominator. Yes. Okay. So the mixed form would be the mixed form of 127 over 26 is 4 and um, 4 and 23 over 26. Okay, I repeat. The mixed form of 127 over 26 is 4 and 23 over 26. All right. Okay, so I hope that clarifies our understanding about about adding and subtracting negative fractions. All right, so before we end, I'd like us to have a story. Would you want to hear a story about the orange chicken? Wow, that's delicious. Okay, the orange chicken, and of course, I love orange chicken, and rice. Do you love it too? Hope you love it. Okay, so let's have a story here about the orange chicken and rice challenge. All right. So let's start. So it says here in the lively kitchen of Chef Mia. Wow. The aroma of her famous orange chicken wafted through the air. Wow. Okay, so it was the day of the annual Flavor Town feast, and Chef Mia was determined to impress everyone with her delicious dish. Okay, that's her goal. Now, as she prepared for her ingredients, Chef Mia realized she had only negative um, three-fourths of a cup of rice left. Oh, so she needed more rice. So she's lacking in rice. Okay, specifically, negative 1/2 cup to serve all her guests. Oh, so with a frown, she calculated how much rice she needed in total. Okay, let's help Chef Mia to solve her problem. So she had only negative 3/4 of a cup of rice left. And she needed more. So when you say more, we need to add, right? Okay, add negative 1/2 cup. All right, so we need to add negative 1/2 cup. Of course, how do we do this? We need to, of course, to list the multiples of 4 and 2. But this is very obvious because even if I list the multiples for us to get our common denominator, so we have 4, and then for 2, multiples of 2, we have 2, 4. Okay, so, okay. All right, so basically here, our, what do you call this? Okay, so for 4, the multiples would be 4. I stop with 4. And for 2, we have 2, 4. All right, so we can say here that our LCD, of course, would be 4. Yes, LCD would be 4. We're now applying math to cooking. All right, so let's further solve this one and erase it. Okay, now since we were able to determine that it's actually that our LCD is 4, let us now convert negative 3/4 and negative 1/2. Okay, so we have negative 3 times and then 4 times. All right, so eventually for us to make our, what do you call this? To make uh, our common denominator the same is we need to be able to change, of course, rewrite, what do you call this? Uh, our fraction. But in this case, do we need to change? Do we need to change negative 3/4 since our, what do you call this? Since our common denominator is 4. Of course not. Of course not. Yes. Okay. So what we're going to do now is just to change negative 1/2. Yeah. Okay. Negative 1/2. Let's just erase this one. Okay. So we have negative 1/2. Okay. We'll multiply negative 1, negative 1 over 2. Okay. We need to multiply them to, okay, we need to multiply them to 2, both negative 1 and 2. Negative 1 is our numerator, and 2 is our denominator. So this will become negative 2 over 4. Okay, so there you go. All right. Okay, so well, we didn't change negative 3 over 4 because, as you can see, the denominator is already 4. Yes. Okay, now we can add them. Okay, so we have negative 3 over 4 plus negative 2 over 4. See? Yes. That's the reason. We only change negative 1/2 by multiplying both negative 1 and 2 to 2. Because our main goal, as I said, is to um, ensure that our common denominator is the same. All right. Okay, let's erase it. Hold on. Okay. So we now have negative 3/4 plus negative 3/4 plus negative 2/4. Okay. Okay, we'll now have 4 as our common denominator, and negative 3 plus negative 2 will give us negative 5/4. Okay, so what is this negative 5/4 that we have now? Okay, let's see. So that negative 5 fourths is, this actually means that she needed, okay, Chef Mia needed negative 5 fourths of cups of rice, which is, if we're going to change this to mixed form, let's change this to, change negative 5 fourths to mixed form. If we're going to change 5 fourths, disregard the sign again. So divide 5 by 4, 1. All right, 1 times 4. 1 times 4 is 4. 5 minus 4 is 1. So that is actually equivalent. Negative 5 fourths is equivalent to negative 1 and 1 fourth. Negative 1 and 1 fourth cups. Okay. So this is what she needed. Okay. The cups of rice. Okay. For her cooking. So what she did is she quickly went to the market. Yeah, Chef Mia, to grab an extra rice, because otherwise she's gonna be lacking in, in ingredients. All right, now the next thing now that she needs. Okay, wow, that's delicious. It's also my favorite. Okay, the next thing that she needs is the sauce. Okay, she needs the sauce. Okay, that's the next thing. Of course, we're done with the problem about rice, but she needed a sauce. Okay, so Chef Mia actually prepared a negative two-third cup of her negative two-thirds cup of her orange sauce. Oranged sauce. Yeah. Okay. That's negative two-third cup. But this time, a while ago, she was lacking, but this time she wants to actually reduce this by negative one fourth. Okay, her sauce, her orange sauce, negative one fourth cup. Okay, so let's further solve this one. Okay, so if she wants to reduce it, so negative two-third, sorry about that, negative two-third minus negative one fourth. Okay, in this problem, we're going to apply what we have just learned, and the rule is add its opposite. Okay, let's add its opposite. So this becomes negative two-thirds plus one fourth. Yes, okay, let's erase this one. So we have negative two-thirds, okay, plus, okay, one fourth. And this time, we can now list the multiples of 3 and 4, which is our denominators, for us to get the common denominator. So by just looking at it, I can say that their common denominator or least common denominator is 12. Yes. Okay. And then now change, of course, your fractions, both of your fraction, which is negative two-thirds and one fourth, so that we'll have the goal of seeing, having the same. We want to convert it so that we can have the same common denominator. Common denominator. Okay. So I will now multiply this by, so negative 2 over 3 will be multiplied, both numerator and denominator will be multiplied to 4. Okay, 4. Okay. So negative 2 times 4 is negative 8 over 12. 3 times 4, yes. And of course, 1 4 2 must also be changed. So both your numerator and denominator will be multiplied to 3. Okay, so we have 3 over 12. Voila. Okay, so we can now add them. So we have now negative 8 over 12 plus 1 fourth. Oh, sorry. Plus, my bad. Plus, I'm sorry. Plus 3 over 12. I'm sorry for that. Yes, we already changed 1 fourth to 3/12. So why would we put it there? Okay, so we can now add negative 8 over 12 plus 3 over 12. Okay, and let's rewrite 12 as our denominator, and negative 8 plus 3 will give us negative 5. Yes, negative 5 over 12. Okay, let's erase this one for us to have a clearer view. Yeah, okay. So again, let's write it. Negative 8 over 12 plus 3 over 12. Yes, that's it. All right. So we now have negative 8 plus 3 over 12. Okay, we now have negative 5 over 12. Sorry about that. Okay, so what is this negative 5 over 12? This is actually your, this is now the result. This will be what's left because, as we said a while ago, she wants to reduce, you know, what I call this, her negative two-third of a cup of her special orange sauce. She wants it to reduce by negative one fourth of a cup. And what would be left for her sauce, the sauce is actually the one being used for your orange chicken, will be negative 5 over 12 cups of sauce. Okay? So she knew it would be, just enough or the right amount to coat her chicken perfectly. So the feast was a huge success. Everyone raved about the orange chicken and rice, including me. And Chef Mia shared her story of adding and subtracting negative um, fractions with the guests. They laughed at how um, little math had actually saved the day. As the sun set over Flavor Town, Chef Mia smiled. She's happy, knowing that both her cooking and her math skills had come together to create a memorable feast. End of story. All right. Now it's your turn for you to have a practice exercise regarding adding negative fractions and, of course, subtracting negative fractions. I hope the examples and story about Chef Mia and her orange chicken and rice challenge help us to understand better and easier the skill of adding negative and subtracting negative fraction. Until next time, bye.